Indirect measurement. You're going to learn to find measures indirectly by applying the properties of similar figures. Basically, this means you're not going to be measuring a missing side with a ruler or a formula chart. You're going to use similar figures and proportions to find that missing measurement. Sometimes distances cannot be measured directly, like with a ruler or formula chart. One way to find such a distance is to use indirect measurement, a way of using similar figures and proportions to find a measure. Triangles ABC and EFG are similar, meaning the sides are proportional to one another and the angles are congruent. That's what similar means. We're going to find the length of side EG, which is the X, the missing side. So here's our similar triangles. We're going to find that length. First, we set up a proportion. Remember back in similar figures, I taught you how to set up these proportions, that the tops have to correspond to one another, the bottoms have to correspond to one another. So I set AB and EF on top because they correspond with one another, AB and EF. AC and EG correspond with one another, so I set those as the denominators. Now I'm going to substitute. I'm going to substitute 3 for AB because that's the length of the side. I'm going to substitute 4 for AC because that's the length of that side. I'm going to substitute 9 for EF because that's the length of that side. And then, of course, you have X for EG because that's our missing side. Now we're going to find the cross products. So none of this is different from similar figures except for the fact that we have an X down here. And remember, 3 times X is just going to be X. This is the XMed method. Cross multiply to get your equation and divide. So here's our equation, 3x equals 36. We found that by doing the cross products. Now we're going to divide both sides by 3 because that is the inverse operation of multiplication, which is what's going on over here with our x. So I divide by 3. That gets rid of the 3's on this side, gets x by itself, which is the goal. And 36 divided by 3 is 12. So the length of side EG is 12 feet. Now we know these are definitely proportional because 3 to 9 is times 3. 4 to 12 is times 3. But if you don't know how to set up this equation, you're only going to be limited to being able to find the missing side, and that's the only question you'll be able to answer. But if the question is, which equation can be used to find the missing side, if you don't know how to get here, you're not going to be able to answer that type of question. That's why it's important to know all the steps. So here's the check it out. This is the time where you're going to have the opportunity to try it. Make sure you're actually trying these things because you need to be able to have the chance to learn from your mistakes. Work all the way through it. If you mess up, that's fine because I'm going to show you how to do it afterward and you can just fix your mistakes. That is the best way to learn. Triangles DEF and GHI are similar. Find the length of side HI. So, here's our similar triangles. DEF and GHI. I want you to go ahead and set up your proportion, substitute your sides, find the cross products, XMed, multiply to get the equation, so then you get your equation, and then divide. Follow those steps, press pause, and this is your opportunity to try it yourself. So first I set up my proportion. DE corresponds with GH, so I set those as the numerators. EF, the hypotenuses, and HI, those correspond with one another. One way that some students like to do it, especially with triangles, Pythagorean Theorem, so you could always label these sides A, B, and C, and instead of writing out the length like this, you could just say A over C, A over C. It's completely up to you. So A is 2, C is 7, and then on the other triangle, A is 8 and C is X. So I'm going to substitute 2 for that DE side. I'm going to substitute, let me put that 2 back in there. I'm going to substitute 7 for EF, substitute 8 for GH, and then of course we have our X. So 2 to 7 equals 8 to X. XMed. Cross multiply to get your equation and divide. Cross multiply. 7 times 8 is 56. 2 times X is 2X. Now divide both sides by 2. 56 divided by 2 is 28. So that side, HI, is 28 inches. Good job. Okay, through problem-solving application, you have a 30-foot building casts a shadow that is 75 feet long. A nearby tree casts a shadow that is 35 feet long. How tall is the tree? So we're going to walk through the problem-solving process. First, you need to understand the problem. The answer is the height of the tree. We got that from the question. How tall is the tree? So we need the height. First, we list the important information. The length of the building's shadow is 75 feet. The height of the building is 30 feet. The length of the tree's shadow is 35 feet. That's the information that we have. So with that information, we're going to make a plan. You're going to use the information to draw a diagram. If you remember, the whole process with problem solving is to draw a picture, make a table, anything that's going to help you. So if you can draw a picture, you need to draw a picture. It doesn't have to be an exact building. You could just draw a line up and a line across. But you have a 30-foot tall building casting a shadow of 75 feet. You have a tree casting a shadow of 35 feet. I drew dashed lines to form triangles. The building with its shadow and the tree with its shadow form similar right triangles. So these two things are proportional to one another. We just have to find the right height of the tree to keep them proportional. So let's solve this. The corresponding sides of similar figures are proportional. So we took the height of the building, which was 30, and put it over the shadow of the building, which was 75. We don't know the height of the tree, but we know the shadow of the tree is 35. Find cross products. 75 times H is 75H. 30 times 35 gave us 1050. Divide both sides by 75, because that's the inverse operation of multiplication. And you get 14. So the height of the tree is 14 feet. Let's look back. Since 75 over 30 equals 2.5, the building's shadow is 2.5 times its height. So you remember whenever I was talking to you about the factors have to remain the same. This is our factor. The tree's shadow should also be 2.5 times its height. Because remember, the factors from the numerator and the denominator have to be the same. So here's your check it out. This is where you have the opportunity to try. A 24-foot building casts a shadow that is 8 feet long. A nearby tree casts a shadow that is 3 feet long. How tall is the tree? Hit pause and attempt this problem. First, you need to understand the problem. The answer is the height of the tree. We got that from the question. How tall is the tree? First, we're going to list important info. The length of the building's shadow is 8 feet long. The height of the building is 24 feet. The length of the tree's shadow is 3 feet. Let's make a plan with that information. Use the information to draw a diagram. 24-foot tall building, 8-foot shadow. We don't know the height of the tree, but we know the shadow is 3 feet. To help us solve, we're going to draw dashed lines to form right triangles. The building with its shadow and the tree with its shadow form similar right triangles. Now, just because you see a right triangle doesn't mean you need to start trying Pythagorean Theorem. We don't need Pythagorean Theorem here. We need a proportion so we can find height of the tree. The corresponding sides of similar figures are proportional. So the building was 24 feet tall. The shadow of the building was 8, so that's a ratio. And then the height of the tree we don't know, but the shadow is 3 feet. Cross multiply. 24 times 3 is 72. 8 times h is 8h. Divide both by 8 because that's the inverse operation of multiplication. And the height of the tree is 9 feet. Let's take a look back. Since 8 divided by 24 equals a third, the building's shadow is 1/3 times its height. So the tree's shadow should also be 1/3 its height. And 1/3 of 9 is 3 feet, so this works.